So we are discussing about the marine geology. If you remember, we already discussed a little bit of what is in the ocean deeps or the ocean depths. I hope you have some idea what kind of a structures at least you would see in the ocean bottom. Of course, as I mentioned, the marine geology, it's very complicated and subject, and marine geology is a separate subject discipline. We are just understand, we are just trying to understand very basic things that what you would see in the ocean bottom. So in the last week also we just discussed the like what are sediments, right? Very basically any kind of a organic or inorganic matter. Right? It's both, right? It's inorganic and organic matter if they are arranged loosely. If we see if the organic matter or inorganic matter put together, like inorganic matter put together, they sometimes they can be rock, but in the sediment they are not arranged in that, but they are mostly loosely arranged. So that's how they have become a sediment. So even I mentioned about like the sediments, they can be generated from different sources, as well as they can be in different sizes, right? Based on the size you can name in different ways. In the simple terms, you know, that's clay, silt, sand, you have heard about these things. But even beyond that, you can categorize sediments based on a more standard procedures, like based on the diameter of these sediments, or even more scientific scale, like more different scales, like it's a Wentworth scale, where you can categorize sediments based on that scale, whether they are clay, silt, sand, or whatever, that's boulders or this. Anyway, it just for your information only. Don't try to memorize these things. And also the size of the sediment, I mentioned last week also, that is it's an indication of the how much energy that these sediments receive. Like for example, if they are in the beach, if they are beach sand, like some sand may be larger, whereas some of the beaches you will see very fine sand. So that again an indication of what kind of a the marine environment, or how much energy, or how much the wave energy. Like if it is a constant size range sand particles, which means the waves are more or less equal, similar. But if they receive different types of waves in different times, then you will have different sizes in the beach. So next time when you visit a beach, you just see the size of the sediments in different places. You will notice they are different from time place to place. So that can be an indication how strong the waves can be. So keep that one in your mind and observe this next time, right? And also I mentioned last week that the sediment can be used to record the sediment or the history of the earth or the sediment, because they are deposited layer by layer, year by year, or decade by decade, or century by century, or sometimes even millions of years they have been depositing the ocean bottom, and that will give some sort of the information for us to recreate or to understand what could have been, or how the earth would have been in the history. Like different layers might have different animals or plant material trapped there, and they might have different trapped air bubbles where you can analyze how much the percentage of carbon dioxide, the oxygen that by that time. So to do that one, you have to get some what we call the core samples. You send some sort of a sediment core, and you take the whole uh, piece of rock or whatever the sediment material out, and you do analysis layer by layer to see what is there, and then you can get a good idea about what kind of animals could have been there, and you can theoretically you can like recreate how the world could have been in the history. Like it's that also very important for a scientist to work on. Right? So as we have already discussed, and these sediments are deposited mainly in the continental shelf as well as in the continental rise, mainly, but as by now you know that some of the sea floor is forming newly here. We discussed last week that called the sea floor spreading, or new sea floor is formed from the mid-ocean ridges. That means they also giving some sediments. I mean, this when they uh, the material come to the surface, they also some sort of a sediment. So they also added new the sediment to the ocean bottom, and the warm water or the hydrothermal vents. You remember that they also produce some sediments. Right? Other than that, we get sediment from the even from the outer space. So, and these are the basically where the ocean gets sediment from. That's the weathering of weathering or erosion of rocks. නැත්නම් පාසාන ජීර්ණයෙන් සහ කාදනයෙන් ජීවීන්ගේ ක්‍රියාකාරීත්වය විශේෂයෙන්ම හොදේ ඉන්න ජීවීන්ගේ ක්‍රියාකාරීත්වයෙන් හින්දා සමහර sediments ලැබෙනවා. ගිනි කඳු පිපිරීම, volcanic eruptions එහෙම නැත්නම් volcanic activities වෙනින්දා වෙන්න පුළුවන්. රසායනික ක්‍රියාවලින් මගින් සාගරයේ වෙන විශේෂයෙන්ම අපි දන්නවා calcium carbonate වගේ දේවල් මුහුදේ වතුරේ විශේෂ මුහුද ආම්ලික වුණාම ඒ ආම්ලික මුහුදු වතුරේ මේ calcium carbonate එහෙම දිය වෙන්න ගන්නවා. ඉතින් එතකොට මේ විදිහට රසායනික ක්‍රියාවලින් මගින් සමහර sediment මුහුදට ලැබෙන්න පුළුවන්. තවත් සමහර තැන් වලට අපි හිතමු මේ මුහුදේ ස්වභාවික ලුණු හැදෙන්න පුළුවන්. මේක මේ ජියෝලොජි වලදී කියනවා evaporites කියලා. evaporites evaporate වෙලා හැදෙන දේවල්. ඉතින් වචනේ සංකීර්ණ වුණාට just salt. විශේෂයෙන්ම salinity ගොඩාක් වැඩි, ලවණතාවය ගොඩාක් වැඩි මුහුදු වල, Arabian Sea වල, ජෝර්ඩන් පැත්තේ එහෙම මේ මුහුදු වෙරළා අයිනේ තියෙන පාෂාණ වනද මේ rocks වල එහෙම මේ ලුණු නිකන් තියෙනවා ස්වභාවිකම හැදිලා. evaporites කියනවා. ඉතින් ඒවත් එක විදිහකට පාෂාණ නෙමෙයි නමුත් ඒවා sediment වර්ගයක්. හැබැයි අපිට කෙලිම කඩලා වුණනම් ගන්න පුළුවන් මේ සම්පතක් විදිහට. හරි ලංකාව වටේ නම් එහෙම ස්වභාවික හැදෙන ලුණු නැහැ. අපිට ලවණතාවය එච්චර වැඩි නැති හින්දා. ඊට අමතරව මේ මීටියෝ එහෙම නැත්නම් උල්කාපාත වලිනුත් අභ්‍යවකාශයෙන් අපිට මේ sediments ලැබෙන්න පුළුවන් මුහුදට. ඉතින් මේවා නම් විශාල ප්‍රමාණ වලින් හම්බ වෙනව නෙමෙයි. නමුත් මේ එක එකක් ක්‍රම වලට ලැබිච්ච sediment තමයි අවසානයේ මේ මුහුදේ තියෙන්නේ. හැබැයි වැදගත්කම තමයි මේ මුහුද නිරන්තරයෙන්ම මේ කියන sediment වලින් තැම්පත් වෙලා අලුතෙන් තැම්පත් වෙලා විශාල විදිහට sediment තැම්පත් වෙලා තියෙන තරම්. ඉතින් මේ sediment විවිධ විදිහට වැදගත් වෙනවා. සමහර sediments කියන්නේ ඒවා minerals, සමහර මූලද්‍රව්‍ය විශාල වශයෙන් තැන්පත් වෙලා තියෙනවා. මේවා සම්පත් විදිහට ගන්න පුළුවන්. සමහර sediment තමයි අපි ඔය oil and gas කියලා මුහුදෙන් ගන්න. ඉතින් ඒ oil and gas විශාල ලොකු සම්පතක්. ඒව හැදෙන්න අවුරුදු මිලියන ගාණක් යනවා. ඉතින් අලුතෙන් හැදෙන්නේ නැහැ. ඇත්තටම මේ තියෙන ඒවා තමයි හැදෙන්න පුළුවන්. දැන් තියෙන ඒ වගේ හැදෙන්න තවත් අවුරුදු මිලියන ගාණක් යනවා. which none of us will be. So likewise, there are many uses of a sediment as well, which we will discuss towards the end when we are talking about the ocean uses. I think මුහුදේ සාගරයේ වැදගත්කම සම්පත් ගැන කතා කරද්දී අපි අවසානයේ ඒව ගැන කතා කරමු. අපි මේගොල්ලෝ දකින්නේ සාගර පත්ලේ තියෙන සමහර දර්ශන පින්තූර mid Atlantic ridge mid ocean ridge එක තියෙන හැටි ඒ වගේම මේ සමහර මුහුදු පතුලේ මේ වගේ දේවල් තැන්පත් වෙච්ච තැන් තියෙනවා. ඔයගොල්ලෝ බැලුවමට නිකන් කිසියම් රටාවක් පේනවා ඇති මේකේ. මේවා කිසියම් රටාවකට තැන්පත් වෙච්ච අපි බලමු ඉස්සරහට මෙහෙම තියෙන්නේ මොනවද කියලා. Right. So that's where actually we stopped last week. And one thing I forgot to mention that the classification of this sediment actually in the very beginning should be next to this one. Basically, we divided the sediment into 4 groups, but in some of the publication they're talking about the 5 types of sediments. For example, in some documents you will something called orthogenic sediment, which is refers to as something naturally, or some sediments that form naturally in the marine environment. Orthogenic means naturally, but it has no any scientific base. So usually we talk about the 4 different types of sediments: the Terrigenous, the Biogenic, the Cosmogenic, and Hydrogenous sediments, which we will come to. Like in this diagram, you will see where the ocean, especially the deep ocean, get this sediment from. The Terrigenous sediments, if you remember last week, I think I mentioned that Terrigenous means the sediment that formed from the rocks, whether they are weathering or erosion of rocks. That sediment get into the sea mainly from the river inputs when they are deposited in the continental shelf, or even beyond that through the sediment, the turbidity currents. I hope you remember now the sediment here. They can flow to the ocean bottom as the turbidity currents, and where they are deposited here as well. And so all these are Terrigenous sediments. The others are the Biogenous sediments, that due to the activities of the organisms, the biological activities of the organism, there can be some sediment formed in the water column, and they can be settled. Right? So actually these biogenic sediments, or sometimes we call the biogenic oozes, once they are settled in large quantities somewhere here, and they are covered with the other type of sediments, especially from the Terrigenous sediments, layer by layer. Right? It can be sometimes hundreds to meters to several kilometers deep sediment would be deposited on top of that Biogenous sediments, and that is actually the source of the oil and gas. The Biogenous sediments, when they are deposited and they are under very high pressure because of the water column above, as well as the other sediment layers, they will be in a very high pressure as well as in the high temperatures. In that particular temperature and the pressure, they start forming this oil and gas. It depends on what temperature and what pressure they are, and decide whether they are going to be natural gas or whether it's going to be what kind of type of crude oil. බොරතෙල් කියලා අපි කියන්නේ ඒ බොරතෙල් වර්ගය එහෙම නැත්නම් ස්වභාවික ගෑස්ද කියන දේවල් හැදෙන්නේ තීරණය කරන්නේ ඒ ප්‍රෙෂර් එක වගේ විශේෂයෙන්ම උෂ්ණත්වය. ඒ වටේ පිටාවේ තියෙන උෂ්ණත්වය. හරි. එතකොට එහෙනම් මේ බයෝජිනස් සෙඩිමන්ට්ස් තමයි ඇත්තටම පස්සේ කාලෙක අපි මේ natural gas එහෙම නැත්නම් oil and gas විදිහට extract කරගන්නවා. So the same terrigenous sediments, they can come from the river, but also they can come as the blown dust. හුලඟෙන් ගහගෙන ඇවිල්ලා මුහුද දිගේ මුහුදේ එන්නත් පුළුවන්. මොකද මේ ළඟදී එහෙම නිවුස් එකකින් හිටියනම් අහන්න නැති අර විශාල මේ වැලි කුණාටුවක් ආපු කතාවක් මට ඇහුණා ලාවට කොහෙද කියලා මට මතක නැහැ. ඒ වගේ නිතර ওই වැලි කුණාටු එහෙම මුහුද හරහා සමහරට අනිත් පැත්තේ තියෙන කොන්ටිනන්ට් එකට පවා යන්න පුළුවන් මුහුදක් කරා. එච්චරම ප්‍රබල සුළං එක්ක මේවා ගියහම ඉතින් මේවා ඇවිල්ලා මේ යන අතරතුරේ මුහුදේ ඩිපොසිට් වෙනවා. ඉතින් ඒවා ඇවිල්ලා සෙටල් වෙනවා. හරි. ඔය විදිහට විවිධ ක්‍රම වලට මේ sediment deposit වෙන්න පුළුවන්, and then they will become, at the end they become marine sediments in general, right? So let's see a little bit further on the marine sediments. I have a small video clip. We can watch that one and then we'll come back.
In this video, we will look closely at the sediment that makes the top layer of ocean crust. Where does it come from? What does it look like? Feel like? Let's start with the vocabulary used to describe sediment size. Though there are many terms used to describe sediments of all sizes, we'll simplify them for this class into 3 categories: muds, sands, and gravels. Technically, gravels are sediment grains larger than 2 millimeters in diameter. Muds are less than 1/16 millimeter. Sands are everything in between. Where is each of these grain sizes found in the ocean? The largest grains, the heaviest, settle quickly in still water and require high energy water to be picked up and carried. The smallest grains require perfectly still, unmoving water to settle out. Ocean environments are separated into 2 major geographic zones: neritic, over the continental shelf, and oceanic, over the slope, rise, abyssal plains, mid-ocean ridges, and trenches. Neritic waters tend to have faster moving currents interacting with surface waters in the shallow bottom. These waters can pick up and shift around larger sediment grains. Rivers that enter here will retain mud-sized sediments in suspension and can carry them quite a distance offshore. Gravels tend to stick close to shore. Fine sands collect in medium energy coves and can be carried out to the edge of the shelf. Muds settle out only in closed-off, no-energy lagoons. Oceanic waters are deep with no currents that touch the bottom. Gravels and sands cannot be transported out here by anything other than floating icebergs, so the sediment that falls here is only the suspended muds. Where do these muds come from that get out to the oceanic zone? Nearby rivers that have a lot of suspended sediment, airborne dust and ash that settles on the surface, and the shells and debris of organisms that live in the surface waters and settle to the seafloor when those organisms die. The oceanic zone represents 4/5 of the world's ocean environments. However, the sediment that collects in the margin environment is the thickest in the world, up to 9 kilometers thick, compared with the oceanic sediment thickness, which increases from 0 at the ridges to 0.6 kilometers at the thickest, oldest edges of the abyssal plains. Even though the sediment that collects in the margin environment represents only 1/5 of the ocean's surface, its sediment volume represents almost 90% of the total ocean sediment. Why? Sediment collects here much faster, at rates from 0.5 to 800 meters per 1,000 years. For comparison, in the oceanic zone, sediment collects at its fastest 1 centimeter per 1,000 years. Pause now. What makes up all these sediments? There are 4 major sources of sediment to the ocean, and of course each gets its own name. We call sediment that originated from rock weathering on land lithogenous or terrigenous sediment. What is it made of? Bits of rocks and minerals. When next to a weathering cliff, like along an eroding coastline, the material is made of bits of the rock in the cliff, and gravity carries them towards the ocean. When dropped by glaciers, these sediments can be quite large and come relatively preserved from the backcountry far inland. We call both of these types of sediments immature because they haven't been modified much by travel. They can be angular and poorly sorted, consisting of grains of all compositions, shapes, and sizes, mostly gravels. When lithogenous sediment is carried by rivers, on the other hand, it becomes mature. Grains decrease in size to fine sands and muds. Why? During transit, the grains are knocked around and hit each other. They physically break down into smaller pieces. They also break down chemically. Most of the material dissolves or is turned into clays and rust. The most resistant materials, predominantly quartz grains, which don't dissolve or turn into clay or rust, remain. Clay minerals are mud-size and are the most common byproducts of rock weathering on Earth's surface. Some of these clay minerals make it out to the oceanic zones, either by being held in suspension near large river deltas or by being carried by winds off desert and mountain areas. We call those clays abyssal clays, as they are found in abyssal plains. We'll return to them shortly. As lithogenous sediment dominates the coastal margins and accumulates at the fastest rates of all sediments there, and also reaches out in its mud-sized form to the deeper parts of the oceans, predominantly as abyssal clay, lithogenous sediments make up the largest percentage by volume of marine sediments. However, because most of this volume stays close to the margins and piles up there thickly, they represent only 45% of the total seafloor surface coverage. The sediment that covers most of the seafloor surface is biogenous, which consists of shells of dead organisms and dominates the oceanic zones. The most important contributors to biogenous sediment are the single-celled autotrophic and heterotrophic plankton that live in the surface waters. Billions of these organisms live and die with lifetimes of days to weeks. Their shells collect on the bottom of the seafloor and contribute to siliceous and calcareous oozes, depending upon whether the shells are made of silica, siliceous oozes, or calcium carbonate, calcareous oozes. The term ooze tells us a lot about the consistency of these sediments. They are all mud-sized, a very fine flour-like material. Larger gravel-sized shells contribute to neritic nearshore sediments where there are large reefs, either tropical coral reefs or colder water reefs made of mollusks like mussels and limpets. We'll return to the oceanic oozes shortly to describe them in more detail. Another type of sediment, called hydrogenous, represents minerals that are produced from ions that were originally dissolved in water. We call that process precipitation. Seawater has many dissolved ions in it, and in numerous locations those ions reach a concentration that is higher than can be dissolved by the water anymore, either because of evaporation of water or because of an influx of dissolved ions. We call that state supersaturated, and you can learn more about this in the seawater chemistry video tutorials. For now, we'll focus on where to find these precipitated hydrogenous sediments. At shallow inland seas where rains are limited and evaporation rates are high, minerals can precipitate in high amounts. These minerals consist of halite, table salt, gypsum, drywall material, and calcite. In some areas of the abyssal plains, dissolved phosphates and manganese become supersaturated and precipitate as nodules that grow bigger over time as new material precipitates atop the older material. Any other place in the ocean where sediment precipitates from solution? Something we discussed in the plate tectonics and earth formation video tutorials? Hydrothermal vents. Hot waters rich in dissolved ions leached from the ocean crust enter the colder seawater. As that hot water cools, it becomes supersaturated with dissolved ions. Cold water can dissolve less than warm water. That's why when cooking, we heat up our water when we want to dissolve things like sugar or salt in it. Hydrogenous sediments are found in many places across the oceans, but they represent less than 1% of the surface area, as they are largely scattered. The most uncommon sediment found in the ocean, but still found in abundances greater than on land, is cosmogenous sediment, meteorites that fall from space, and tektites, which are bits of Earth's crust that have been ejected into space after a meteorite impact excavates a crater. This ejected, excavated crustal material melts as it exits the atmosphere and solidifies as it falls back down, producing a spherical teardrop-shaped glass nodule with eroded pits created by its journey back down through the atmosphere. Why are these found in the oceans in more abundance than on land? Simply because of the slow sedimentation rate of the oceans. Where sediment collects at rates as low as 1 centimeter per 1,000 years, it's easier to find the tektites and meteorites that fall among them. Pause now. Clays and siliceous and calcareous oozes that form there. Are all three found in the same location? In most cases, one is the dominant. Why? Abyssal clays, remember, are lithogenous or terrigenous, so they will dominate near high-volume rivers with large deltas. Without rivers nearby, abyssal clays come from the settling of airborne dust and ash that's been blown from the land. If there are nearby deserts with high wind activity, the rates of abyssal clay settling can be comparable to that of calcareous or siliceous shells. So the settling rate of abyssal clays in the deep oceans can be anywhere from 1 millimeter to 1 centimeter per 1,000 years. We call the organisms that live in the surface waters plankton, free-floating, can't swim faster than currents. If they are autotrophic, make their own food, they are the bottom of the food chain and are referred to as phytoplankton. Heterotrophic plankton are referred to as zooplankton. Diatoms are phytoplankton with silica shells, SiO2. Coccolithophores are phytoplankton with calcium carbonate shells, CaCO3. Radiolaria are the most common zooplankton with SiO2 or silica shells. Foraminifera are the most common with calcium carbonate shells. These 4 organisms play very important roles in the world's oceans, and it's valuable to memorize these names and shell types now, as they will appear many times throughout future video tutorials. We'll review one more time, then you'll take a quiz. Autotrophs, diatoms and coccolithophores. Heterotrophs, Radiolaria and Foraminifera. Silica shells, diatoms and Radiolaria. Calcareous shells, coccolithophores and Foraminifera. Pause now. Organisms thrive, and hence their shells dominate the oceanic muds on the seafloor. Calcareous-shelled creatures are the most abundant organisms in the world's oceans, so theoretically their shells should dominate all deep-sea muds. That would be true except for 2 things. First, in areas where deep water rises to the surface, a process called upwelling, silica-shelled organisms thrive. These waters are cold and filled with nutrients. Nutrients are dissolved ions that autotrophs pull from the water to use for building cells and shell material. All autotrophs require that the water have nutrients. Heterotrophs get their cell-building and shell-building nutrients from their food. Since autotrophs make their own food, they need to get their nutrients from the surrounding water. Silica-shelled autotrophs are adapted to cold, nutrient-rich water, while calcareous-shelled autotrophs tend to prefer warmer waters and don't require as high a nutrient content. So siliceous oozes dominate under areas of upwelling, though some calcareous shells might also be found in these oozes, along with abyssal clays. The siliceous shells dominate. Where are these areas? Upwelling can occur anywhere at any time, but it is typically found year-round in the waters surrounding Antarctica and along the eastern edges of the ocean basins along the equator. We'll learn more about why that's true in the video tutorials that deal with ocean currents. So everywhere else there should be calcareous oozes. Not quite. There's one remaining issue to take into account. Calcareous shells will dissolve in acidic waters, and as water gets deep, Cold temperatures and high pressure mean more carbon dioxide is dissolved. More carbon dioxide means more acidic. For more information, refer to the video tutorial on carbonated oceans. For now, we focus on the result. Though calcareous creatures might exist in the surface waters, their shells will dissolve en route to the seafloor if the seafloor is deeper than the calcium carbonate compensation depth, otherwise known as the CCD. The CCD is the depth at which the acidity of the seawater is high enough to dissolve these shells in their normal abundance, and thus no calcareous shells accumulate below this depth, unless they collect faster than they can dissolve. For our purposes, that means they should be absent. This depth varies in the oceans, but is on average around 4,500 meters. That means the deep abyssal plains will not have calcareous shells accumulating. Only siliceous oozes or abyssal clays can collect at these depths. So let's use this information now to describe the distribution of oceanic muds across the world's oceans. Notice the distribution. With what seafloor feature do these calcareous oozes correspond? Mid-ocean ridges, the shallowest parts of the oceanic zone. Siliceous oozes dominate at the eastern equatorial zones and in polar regions as previously discussed. The rest of the oceans is dominated by abyssal clays. Pause now.
Right. It might look a little bit too much for you, perhaps. Actually, I just downloaded this video just before the lecture. Even I seen this video along with you. That described most of the thing actually related to the sediment basics thing. So that actually saved a lot of time for us to go through the lecture. But I'll very briefly go through this the types of sediments as well as the other methods. Like so, as video so discussed, basically there are 4 different types of sediments: lithogenous, or any sediments that form from the rocks. Therefore, that there are terms that earth produce, because earth means the usually we refers to the rocks. So earth produce sediments, then the biogenous organic matter, that's the life produce sediment, then the hydrogenous, that anything deposited from the seawater itself. So water produce sediment, and the last one, the cosmogenous or outer space, universe produce, right? The simple terms. So that's how these are the basic type of sediment based on their origin, how these sediments are formed. Here it's given the percentages, usually the how much ocean floor is covered. The Terrigenous sediment is covered about 45%. That's cover, and Biogenous sediment cover 55%, but volume wise, there's a lot of Terrigenous sediments because the volume is very high compared to the others, right? So as I mentioned before, some the classifications, they talk about 5 different sediments, like Terrigenous sediments, biogenic, orthogenic sediment, volcanogenic sediments, and cosmogenic sediment. But it's not very orthogenic, something like a sediment naturally built in the naturally formed in the ocean, and the volcanogenic are the anything derived from the volcanic activities. But again, volcanic activities also some sort of a earth produce sediment. So there's not much science here. So we'll stick into the other classification, right? So very basic, very briefly we'll go through like a Terrigenous sediments is the most abundant sediments, and then they are come from the either from the erosion or the weathering of the rocks, and also the volcanic eruption. As you can see here, the volcanogenic sediment, there's no science against because it's a part of the Terrigenous sediment. So but our classification is much better, right? So so since you already know these sediments are taken to the sea from the mainly from the rivers and then deposited in the continental shelf, and even go beyond that through the turbidity currents or the turbidity deposits into the deep water. So which you already know. You may know that already this what we call the rocks. Now what we call the sediments, the rocks actually they can be like granite or basalt. Actually they are originally the magma. අපි ඔය මැග්මා කියන ඒවා තමයි ඇත්තටම කූල් වෙලා සීතල වෙලා කාලයක් තිස්සේ මේ ඉග්නියසස් රොක් බවට පත් වෙලා ඒවා වේගෙන් කූල් වුණොත් තමයි බේසෝල්ට් බවට පත් වෙනවා. එහෙම නැත්නම් හිමින් හිමින් කූල් කාලයක් තිස්සේ කූල් වුණොත් තමයි මේ ග්‍රැනයිට් කියන අපි ඔය කළු ගල් තියෙන මේ බවට පත් වෙන්නේ. හරි. ඒකට බේසෝල්ට් අපිට මතක ඇති අපි කිව්ව මුහුදේ කන්ටිනෙන්ටල් ඕෂනික් ක්‍රස්ට් එක හැදිලා තියෙන්නේ බේසෝල්ට් වලින් කිව්ව මතක ඇතිනේ. more denser basalt. එතකොට ග්‍රැනයිට් වලින් තමයි continental crust එක හැදලා තියෙන්නේ. එතකොට මේ දෙකම ඇත්තටම අවසානයේ මේ මැග්මා. මේ දැන් මුහුදේදී මේවා ඉක්මනට කූල් වෙනවා. මුහුදේ වතුරත් එක්ක ඒක නිසා තමයි basalt. ඒකට මේවා බලන්න මේ අපි පොඩ්ඩක් මේවා ගැන දැනගත්තාම හුඟක් දේවල් explain කරන්න පුළුවන්. Right. Anyway, so the ocean get this Terrigenous sediment or the earth produced sediments from rivers like here, and the volcanic eruption, and the as we discussed before that the blown dust or the that dust carried from the wind, they can go across the ocean and deposited. And this is one example. You can see even the satellite images, some blown dust through the Gobi desert, just about China and Mongolia. Gobi dust, sorry, Gobi desert again. Haratin. Metine wage sediment විශාල වශයෙන් උලගත් එක්ක ගහගෙන ගිහලා deposit වෙනවා. So they become Terrigenous sediment or the Terraginous sediment, right? So the second type is the Biogenous sediment. So they are the sediments that deposit from the activities of the marine organisms. So there are two types of the Biogenous sediments. There are calcareous oozes, that's calcium based, and the siliceous oozes or the silica based or the carbonate based oozes called the calcareous oozes, and the silica based oozes we call the siliceous oozes. As you've seen from the video, basically the calcareous oozes are formed from foraminiferans and theropods as well as coccolithophores, and then the siliceous oozes from the protozoans, and I think even the some algae also can form this siliceous oozes as well. Right. So that's how they are formed. This is actually the calcareous oozes or calcium carbonate or carbonate based oozes, and the siliceous oozes or silica based oozes. Right. So the foraminiferans, diatoms, radioradians, and the other protozoans, they are the main source of these Biogenous sediments. You can imagine how many of them they can deposit in sometimes few meters to few kilometers deep layers of biogenous sediment. You can think of how big or how large plankton blooms can be. අහලා තියෙනවනේ අපි නේද plankton blooms ගැන. සමහර ලාට සමහර කාලවලට සමහර තැන්වල විශාල blooms හැදිලා nutrients වැදුනහම blooms හැදිලා මේවා එහෙම කාලයක් ඒවටම nutrients නැති වෙලා oxygen නැති වෙලා ඔක්කොම මැරිලා deposit වෙනවා මොහොත පතුල. So that blooms are the ones that eventually become biogenous sediment, and once they are covered with the other sediments and over the millions of years they can become, actually not all biogenous sediments become oil and gas. If they have the right condition, right pressure and the right temperature, then they become natural gas or the oil. And this is an example. This is in Indonesia, and this kind of a sediment called shale, actually. Shale, SHAL is shale. මේ ඔයිතියේ මේ shale දැන් මේක නම් මේ වෙරළයිනේ තියෙන එකක් නේ. හැබැයි මේවා ගොඩාක් ගැඹුරු මුහුදේ තිබිලා ඇත්තට මේ වැඩිපුරක් හැදලා තියෙන්නේ මේ organic matter, ඒ කියන්නේ මේ biogenous sediments මේ තියෙන්නේ. අනිත් sediments යම් කිසි ප්‍රමාණයක් deposit වෙලා තියෙනවා. එතකොට මේවා මේකෙන් කියලා turbidite කියලා, ඒ කියන්නේ මේක black shale එක විතරක් නෙමෙයි, මේ අනිත් ඒවාත් mix වෙච්ච sediment එකක්. මේවා හැබැයි උඩ මුහුදු පතුලේ අර කියපු වගේ ප්‍රෙෂර් එක යටතේ ඒ උෂ්ණත්වය යට තිබුණා නම් එහෙනම් මේවා ගෙමුත් oil and gas හැදෙන්න පුළුවන්. හැබැයි මේ වගේ තැනකදී මේවා එහෙම හැදෙන්නේ නැහැ. හරි. Right. So these are some of the examples or the organisms causing these calcareous oozes, the foraminiferans, the pteropods and the coccolithophores. And you can imagine, like this is a satellite image showing some coccolithophores, like these coccolithophores. They are very abundant in the ocean. So they can form large blooms where even a satellite can detect their large blooms. So they are the one actually become biogenous sediment eventually. This is one example. It's called the White Cliffs in Dover, in UK, right, in the southern UK, somewhere here. Very famous tourist destination. You can search in the internet, search for the White Cliffs in Dover, where this rock look like the white rocks. Actually, they are formed due to the biological activities or deposited for millions of years, and they have become sort of rocks, white rocks, but they are actually the biogenous sediments. All right. And that video also talks something about this carbonate compensation depth, right? CCD we call it, not the Cost Conservation Department, CCD. This is carbonate compensation depth. In the deep waters, as you may know, the more carbon dioxide is dissolved, right? We know that the carbon dioxide gas, they can dissolve easily under high pressure. Since in the ocean bottom, when there is a high pressure, there's a lot of carbon dioxide being dissolved, and because of that, the acidity of the bottom waters is very high, and that's where the carbonates are dissolved in that acidic waters, right? And beyond this, like a sort of a layer, the because of the high pressure, more carbon dioxide is dissolved, making the water more acidic. Right? And density is also high because this temperature is low here. The acidity is high and the density is high because of the low temperature. You know, when the temperature is low, the density increases. So then these waters, after this depth, all the most of the carbon dioxide, so the carbonate will be dissolved, and anything above this, the carbonate will be not dissolved very much, and that layer we call the calcium carbonate or the carbonate compensation depth. So that video also discusses, like in the in some areas you will have the deposited calcium carbonate, especially in the when there is no enough depth, or in the not in the shallow areas, you will see more calcium carbonate or the carbonate deposit, but not in the very deep area. So that's mainly because of they can dissolve, right? So siliceous sources formed radiolarians and diatoms in these pictures, right? So the third type of sediments are the hydrogenous sediments. That's sediments derived from the deposition of from the seawater itself. So we call it a precipitation from the sea. Some of the examples are the carbonates, as you have seen from that video. In some areas in the ocean where this evaporation is high and the freshwater inputs are low, when in that case some of the minerals start depositing themselves. So some of them are carbonates like this, aragonite and calcite. Just forget about these names, just the geological names. And then also other type of hydrogenous sediments are called oolites. මේ වචන මතක තියාගන්න ඕනේ නිකන් අපි මොනවද කියලා විතරක් දැනගන්න කියන්නේ. ඒ වගේ ඩිපොසිට් වෙනවා සමහර තැන්වල as hydrogenous sediment, right? So the phosphorites for the other example, they're all hydrogenous sediments. In some areas in the ocean, there are large deposits of this kind of a phosphorus based phosphorite deposits. You see, then if you have this kind of a large deposit in somewhere, it could be a really good source where you can manufacture fertilizers. Right? We don't know in the ocean around our country if we have some like deposits of these phosphorites, and then that would be a huge source. අපිට එතකොට වෙන රටවල් වලින් ගෙන්නන්න ඕනේ නැහැ. හැබැයි ඉතින් අර ෆොස්ෆේට් නිදි තියෙනවනේ නේද එපාව දෙන්න. ඒවත් අපි කරන්නේ ෆොස්ෆේට් පාෂාණ ටික රට යවලා ආයි ඒ වගේ පොහොර ටික අපහු මෙහෙට ගෙන්නනවා. So unfortunate, we could have produced some fertilizers our own, but we don't have much nitrate sources, so we might need to import some, but at least we have the phosphorus sources, right? And the very important type of hydrogenous sediments we call the manganese nodules. මම හිතන්නේ ඔයගොල්ලෝ මේ වචන කවදාවත් අහලා නැතිව ඇති. Manganese nodules. This is actually you have seen that some of the images of the ocean bottom I told that with some sort of a some pattern in the sea bottom. That is because of the deposition of these manganese nodules. actually even scientists has no much idea why and how these manganese nodules are formed, but like the mixture of some ions like some the metals like iron, copper, cobalt, nickel. Now they become like together making small balls, right? Just like a potatoes. They can be larger or smaller than potato, and they are deposited in a large amount in the ocean bottoms. They have been like they can be 1 to 10 millimeter by deposited annually, and they become like a potato size or even larger, and they deposited in a huge amount of these manganese nodules. Um, and some scientists say that these nodules start depositing around the teeth of the sharks. You might have seen sharks lagi මේ teeth තියෙනවනේ මෙන්න මේක මේ deposit වෙන පටන් ගන්න මේ sharks ලගේ teeth වටේ කියලා තියෙනවා, but I don't know හරි චර sharks දත් තියෙනවද දන්නේ නැහැ නේ deposit වෙන, but anyway, no matter how they deposit, but you see, if in our ocean, if you have this kind of manganese nodules in large quantities, so you can extract them, and they can be a really good sources of manganese, iron, nickel, cobalt. I mean, they are very important metals or the minerals that you can even export. But unfortunately, these are in a very deep waters, several kilometers perhaps. So taking them to the surface going to cost a lot of money. You need a deep water explorations, which going to cost. For the moment, from the present market price, if you are extracting these minerals from the ocean, the price will be several 100 times the cost than you extracting them from the land. So not economical at the moment, but in the future, so they can be a very good source of that we can extract the earth minerals. Right here, you see this the deposition of manganese nodules, and this is a cross section of these manganese nodules, how they are deposited layer by layer, and yes, and actually some of the countries already they are extracting these manganese nodules, but we don't know whether we have these manganese nodules in around the ocean, right? All right, the last type of marine sediments are the cosmogenous sediments, or the universe produce sediments, and they're mainly produced from the meteors that are bombarded or that reach in the earth, because every moment these meteors are coming to the earth, but they, because of their resistance and in the earth's atmosphere, they are just burnt and then make into smaller pieces, or they become actually dust, and they are continuously being deposited everywhere, and they are part of this cosmogenous sediments. And some of the examples for cosmogenous sediments are called these tektites. හරි ඔයගොල්ලෝ කවදාවත් අහලා නැහැ මේ tektites කියලා මේ දෙයක්. හැබැයි මේ tektites මම හිතන්නේ පොඩි පින්තූරයක් තිබුණා. අර වීඩියෝ එකෙත් කතා කරා මේ tektites කියලා જાතියක් ගැන. මේ තියෙන්නේ මේ tektites ඇත්තටම අර මේ meteors වලින් මේ වගේ පෘථිවියට වේගෙන් ඇවිල්ලා වැදෙද්දී සමහර ඒ particles they are bounce back මේ වැදිලා වේගෙන් ඇවිල්ලා වැදෙද්දී bounce වෙලා උඩ ගිහිල්ලා ආපහු වැටෙනවා. මෙන්න මේ process එකේදී ඇත්තටම මේ මේ particles වලින් glass වගේ glassy වීදුරු වගේ දෙයක් හැදෙනවා. මෙන්න මේවා තමයි මේ මොකද මේ පෘථිවියේ මේ වායුගෝලයේ තියෙන අර ඉහළ උෂ්ණත්වයකට මේවා රත් වෙලා මේ ග්ලාස් වගේ බවට පත් වෙනවා. මේවා තමයි මේ ටෙක්ටයිල්ස් කියලා කියන්නේ. අපිට හිතා ගන්නත් බෑ එහෙම මේ කොහොමද වෙන්නේ කියලා. හැබැයි විශාල උල්කාපාත පවා කියන්නේ ඒ වැටෙන ඒවාත් පවා වායුගෝලයේදී අපි දන්නවනේ ඒවා කුඩාම දේවල් වලට විනාශ වෙලා යනවා කියලා ගිනි අරගෙන. ඒක නිසා මේකත් අපිට විශ්වාස කරන්න පුළුවන් එහෙම දේවල් වෙනවා කියලා. So anyway, this is how this what you call the tektites are formed. And then මේ හඳේ අපි දන්නවනේ ඔය අර හඳේ තියෙන ආවාට කියලා කියන්නේ නැත්තේ ඒත් ඒ වගේ මේ ඔය meteors උල්කාපත වැටුණු තැන් ඒ වගේම තමයි පෘථිවියේත් සමහර තැන් තියෙනවා මේ උල්කාප වැටුණු තැන්. මේ උදාහරණයක් මේ තියෙන බෙරිංග meteor කිලෝමීටරයකට වඩා ලොකුයි මචං. ඔව් කිලෝමීටර 1.2 kilometer. You can see from the satellite image this is a meteor crater making හැදිච්ච සිදුර තාමත් දැක් ගන්න පුළුවන්. ඉතින් මේ තියෙන එකේ මේ බිත්තියේ බැලුවොත් එහෙම බලන්න මේ සුදු පාට ලේයර් එකක් වගේ පේනවා ඒකට. මේ ඇත්තටම මේ ඉරිඩියම් කියන මෙටල් එක මූලද්‍රව්‍ය. ඉතින් මේක පෘථිවියේ හරීම අඩුයි මේ ඉරිඩියම් කොහේ හරි ඩෙපොසිට් මේවා මේ එතකොට මේ ඉරිඩියම් ඇවිල්ලා තියෙන ඇත්තට මේ උල්කාපාත වලින්. ඒ කියන්නේ වෙන ග්‍රහ ලෝකවල තිබුණ ඉරිඩියම් කොහෙන් ආවද දන්නේ නැහැ. ඉතින් ඉස්සරහට පේනවා නේද දැන් මේවා තව රත්තරන් තියෙනවද දන්නේ නැහැ කොහෙද. ඉතින් මේ මිනිස්සු මේ වගේ එක්ස්ප්ලෝරේෂන් කරයි. විශේෂයෙන්ම මේ පෘථිවියේ මේ මිනරල්ස් නැති වෙලා ගියාම අපි පාවිච්චි කරලා මේ වගේ ගණන් ගොඩාක් වැඩි වුණාම එතකොට තමයි මේ වගේ වැඩිම වටිනාකම එන්නේ. එතකොට මේ වගේ කොස්ට් එක ගොඩාක් වැඩි. එතකොට වෙන ග්‍රහ ලෝක වලට ගිහිල්ලා මේව හොයාගෙන එන්න තරමට සමහරටවත් වෙන්නත් පුළුවන්. Right? We don't know. Anyway. So anyway, that's a little bit about the marine sediment. So as you can see some of the in the world map you can see where these sediments are deposited and how much. Like in this world map, it shows the thickness of the marine sediment. So the color indicate the thickness in the meters. Like a dark blue means less than 250 or 200. Light blue somewhere 200 to 700 or 600. Like the green around 1000 to 2000 to 2050, and then yellow 5000. Likewise the red colors are more than 10 kilometers deep, right, in some areas. So කොහෙද ලංකාව? It's here. බලන්න මේ ලංකාවට ඊසාන දිග පැත්තේ බලන්න මේ තියෙන කරවත පාට කිට්ටුනේ කියන්නේ ලොකු ඩිපොසිට් තියෙනවා. විශාල කැඹුරට ඩිපොසිට් චෙට් ඒවා තියෙනවා. So that's where we might have some future prospects. හරි කුකුලන්ට ඉස්සරහ කාලට ocean exploration වලට යන අවස්ථාවක් හමු වෙනවා. These are the places to look at. We don't know what is in this sediment. Right? There can be a lot of very valuable minerals, and this is another world map with showing the world map with different types of sediments. I mean, this is very rough map based on the available info. So the yellow color means continental margin sediments, which means basically the Terrigenous sediments. And purple is calcareous oozes. So just basically what is around Sri Lanka. No indication of any hydrogenous sediments. You see these areas where you have a lot of hydrogenous sediments. But these maps, as I mentioned, these are very basic maps without much exploration. Actually, we don't know anything about our ocean. Not there is some experiment, but not really deep waters. We haven't done any deep water explorations looking for anything other than the oil. But we'll talk a little bit in the under the marine resources towards the end, right? So that's how the basically the marine sediments. And in this image, you see the Grand Canyon in Colorado in US. ඔයාලා තියෙනවනේ Grand Canyon ගැන. දැන් මේ Grand Canyon බලන්න මේ deposit වෙලා හැදිච්ච ඒවා මේවත් ඇත්තටම Terrigenous Sediments, sedimentary deposits. දැන් මේවා තියෙන්නේ ගොඩබිම, කියන්නේ මුහුදේ නෙමෙයි තියෙන්නේ. හැබැයි දැන් මේවා මේකෙන් කියන්නේ කියන්නේ ඒ කාලේ මුහුද තිබිලා තියෙන්නේ මේ පැත්තේ. කියන්නේ මෙච්චර දුරට ගොඩබිම ඇත්ත මුහුද තිබිලා තියෙන්නේ අතීතේ. දැන් මේ මුහුදේ යට තිබුණු අර sedimentary deposits තමයි අර අපි කතා කරානේ මොනවද මේ canyons තියෙනවා කියලා මේ continental shelf එකේ. දැන් ඉස්සර කාලේ තිබුණ මේ continental shelf එක තමයි ඇත්තටම අපි මේ දැන් දකින්නේ. මුහුද recede වෙලා මුහුද අපස්සට ගිහිල්ලා හැබැයි continental shelf එකේ තිබුණු ටික දැන් අපිට ගොඩබිම පේන්න තියෙනවා. මේවා සමහර තැන් උඩ දැකලා ඇති ගොඩාක් deep valleys. තාමත් ගැඹුරට ගිහිල්ලා තියෙන valleys. කවුරු හරි දැකලා තියෙනවද දන්නේ නැහැ. හරි. මමත් දැකලා තියෙනවා වීඩියෝ වලින් හැබැයි. Very important tourist destination again. And this is where you can see the actual images of manganese nodules deposit in the ocean bottom. And this is the Jordan Sea, as I mentioned before, the evaporites or the hydrogenous sediment deposits. This is the natural salt. The natural salt deposited in the Jordan Sea, right? අවස්නාවට ලංකාවට එන මේවා නැත්තම් අපිට කෙලින්ම කඩලා ගන්න තිබෙන sea salt, right? Likewise, this is San Francisco Bay, where you will see the lot of evaporites deposit in here. All right, so that's about the marine sediments. අපි පස්සේ කාලෙක වැඩිපුර ටිකක් කතා කරමු resources ගැන කියද්දී වෙලාවක් හම්බුනොත්. Other than that, that's all about the marine sediments. I hope you got some idea. Might think a little bit difficult, of course, since you're listening this for the first time. And geology is not most of us the favorite subject, but anyway, yeah, you just need to have a very good or very basic knowledge about the types of marine sediments, especially the uses and how they can be used. And that's all for the day. And then in the next week, we will start with a brand new topic, especially one of, I hope you will enjoy, because that is where we'll talk about the movement of the ocean, especially the waves, tides, the currents, and that is very much not like the geology. We haven't seen anything, but waves, currents, tides, something that we are all familiar with, and we will see how these waves are formed and how the tides are formed, and what are the currents and waves and tides, are they same or different, and how they are formed, and how they influence in particular, how they influence us in many different ways. So that will be a really interesting topic to discuss for all of us. So stay tuned for that one next week, right? So that's all for the day. If you have any questions or comments, now is the time.